welcome to the Absolute Recap Biology Edition. I'm your host, Melanie Kingett, and I'll be your guide to scoring a 5. Here at the Absolute Recap, we aim to maximize your understanding and minimize your need for memorization. Each episode will review content, skills, and test-taking tips to help you succeed in May. Your recap starts now. Hi, and welcome to the Absolute Recap Biology Edition. Today's episode will recap energy in ecosystems. Let's zoom out. We're in Unit 8, Ecology, Topic 8.2. Our big idea is energetics. Energy is the spice of life. As living things, we require a constant input of energy to maintain organization, grow, and reproduce. If energy is being continuously transferred and often lost as heat, why don't living things run out of energy? Well, we can. A loss of energy flow or order results in death. It all comes down to a numbers game in the end. And so, organisms have evolved some very unique strategies to acquire and use energy efficiently. Let's zoom in. Body temperature is one of the most crucial components to regulate. Some organisms are able to maintain their body temperature internally, whereas others rely on the environment. Endothermic organisms, endo meaning inner, use thermal energy created by metabolism to maintain homeostasis. Recall that metabolism is the sum of all chemical reactions occurring within an organism. And despite our best of intentions, each transfer of energy from one molecule to the next is inefficient. The energy lost as heat is utilized by endothermic organisms to keep their internal body temperature stable. It's no surprise then that endotherms also have great insulating structures, like the blubber of whales and feathers of birds. They also have behaviors to regulate heat, like shivering, sweating, or panting. Endotherms can survive at extremely low temperatures, but require a constant input of food to keep their heater going. In contrast, ectothermic organisms, ecto meaning outer, don't have internal strategies or structures to maintain body temperature, so they must rely upon the environment. Ectothermic organisms, like invertebrates, fish, amphibians, and reptiles, make behavioral changes, like moving into the sun or grouping around other organisms. The body temperature of aquatic ectotherms is typically very close to the surrounding water. There are even fish in the Antarctic waters that have special proteins in their blood acting like antifreeze. Some may say that the only biological goal is to survive long enough to reproduce and pass on your genes. There are even those tragic stories of organisms perishing during the act of copulation, a sad ending for some male praying mantises. Organisms have evolved unique reproductive strategies in response to energy availability. For example, some plants and animals reproduce seasonally. Angiosperms may produce pollen, the male gamete, only at times of the year when its corresponding pollinators are most active. Other plants are biennial, with separate years to focus energy on growth or reproduction. Some animals only reproduce in the spring and summer during warmer temperatures when food is more abundant. Some insects will enter reproductive diapause, a temporary halt in growth and development when environmental conditions are not favorable. Each of these strategies ensures the same thing. Spend the energy only when it's advantageous. Get the most bang for your buck. During the 2008 Beijing Olympics, swimmer Michael Phelps reportedly consumed 12,000 calories a day. He also won 8 gold medals. Calories are used to describe the energy potential of food. Scientists prefer measuring heat energy in joules, which are SI. For reference, your average Reese's peanut butter cup is about 200 calories, and most food labels reference a 2,000 calorie diet. But energy is energy, and regardless of the measurement strategy, it's still a numbers game. A net gain in energy results in storage or growth, whereas a net loss of energy results in loss of mass and ultimately the death of an organism. This is the foundation of any weight loss program or Olympic training schedule. How much energy are you taking in versus how much energy are you using? In the natural world, organisms need maximum efficiency and energy storage strategies. A meal isn't always easy to come by or chase down. Regardless of your ecological model, the base or start of the food chain or web includes primary producers. Autotrophs capture energy from physical or chemical sources in the environment, providing energy for each trophic level above. Photosynthetic organisms like algae and plants capture energy from sunlight, where chemosynthetic organisms like nitrogen-fixing bacteria obtain energy from small inorganic molecules. About 10% of available energy is transferred from one trophic level to the next, as heterotrophs consume and capture energy in the carbon compounds of other organisms. Since there is less energy available, the number of organisms supported also decreases. There is far more grass than there are prairie dogs, and even less coyotes eating the prairie dogs. Mufassa's circle of life in The Lion King was somewhat accurate. If you have a disruption at the producer level, like a change in the amount of sunlight, you can expect a domino effect in the number and size of the other trophic levels in an ecosystem. To recap, the highly complex organization of living systems requires constant input of energy and the exchange of macromolecules. Each ecosystem has unique organisms with a variety of strategies for energy finding, conserving, and using. So spend your calories wisely. Coming up next on the Absolute Recap Biology Edition, population ecology. Today's question of the day is about conversions. How many joules are in a kilocalorie? For the answer to today's and future questions, please follow us on Instagram at TheApsoluteRecap. That's the APsolute recap. If you are a student with questions or a teacher with suggestions, we'd love to hear from you. If you have a biology topic or another AP subject you would like us to cover on the Absolute Recap, please email us at TheApsoluteRecap@gmail.com. That's the APsolute recap@gmail.com. The Absolute Recap is produced by Brad Kingett with music by Zach Caruso. Please remember to rate, review, and subscribe wherever you get podcasts. Time's up, pencils down. Thank you for listening to the Absolute Recap Biology Edition. AP is a registered trademark of the College Board. Copyright 2020, Absolute Recap, LLC, all rights reserved.